All right, we're going to start section 5.3 now. Welcome back to Coronavirus 2020. I can't think of a better way to spend this quarantine period than doing some algebra. We're in section 5.3. I'm going to jump ahead to example 5 because the first examples are just too easy. The big key to remember in section 5.3 is if our denominators are the same with these rational expressions, we can add the numerators straight across. We're done. All we do is combine everything and then see if we can whittle anyway. However, if the denominators are different, then we treat it like a regular fraction. We have to find the least common denominator. So you're going to look for the LCD if they're different. Speaking of different, look, this one's different. Now, again, with 5.3, we go back to the same rule we're talking about in every section of chapter 5 is start by factoring. We have to factor first before we know what's the same and what's different. So I have to factor this denominator out, and I'll just rewrite this. I'll rewrite the whole thing down here and then go across. So in this case, I'm leaving the numerator the same because I'm simply concerned with my denominator. I have to factor this out. So if I get x minus 3x plus 1, that gives me my negative 3 here, and it gives me a difference of negative 2. And then I'm going to add my 3 over whatever this is. Well, it's a perfect square minus perfect square. We still use our rules. Don't forget the perfect square minus a perfect square rule or our cube rules. So perfect square. A perfect square minus a perfect square is our plus or minus. Now we see everything factored out. We see all our pieces. So our concern right now is to find the LCD. Now, I'll talk about, I think, the quickest way to find the LCD right now, and then I'll kind of skip over that explanation after this. I feel the quickest route for an LCD is simply take it piece by piece. Start left and work your way right. And in this case, you're going to take everything from the first expression. So I've got an x minus 3 and an x plus 1. Done with that one. Now I move over here and I just start taking any new piece that I find. X plus 3. That did not appear, so I include that. X minus 3, I already have it, so I don't need that one. So my least common denominator is this whole chunk. That means when we're done, we will have that on the bottom. That's what we'll end up with as our LCD. Now, to change the numerators, we're going to look for what is different. You can write that down, you can just remember it. Look for what's different in the denominator, or what's missing. Maybe I should say missing. That might sound a little better. Look for what piece is missing. When you find that, multiply the numerator. Okay, so multiply the numerator by what piece is missing. I'm going to work up here. I'll erase this in a minute. Well, that's our rule. I can erase that now, actually. I'll use my sock eraser in this case because it's right in my hand. Okay, socks. We don't need those during the pandemic. So what I have is a negative 2 in my first numerator. And I need to look for what's missing from my denominator here and the LCD. I have an x plus 3 in my LCD. I don't have it here. So I have to multiply my x plus 3 by that piece. Now I go to my next one, and I know that once I multiply the numerators, this is what I'll have on the bottom in my denominator, because I'm doing this like a fraction. That's why I'm not spending a ton of time on how to do this. In a fraction, when you're setting up your LCD and you're trying to make your fractions the same, equivalent with the same denominator, you multiply both the denominator and the numerator by what's needed. I'm just taking that step out because I know that's going to be my denominator, and I'm going to add my numerators across. So I'm missing an x plus 3 here. Then I go to my next piece, And I'm going to multiply 3 by whatever's missing here. I have my x plus 3, I have my x minus 3, I'm missing my x plus 1. So I multiply by x plus 1. There's my numerator. Now I have to carry out the work, I have to distribute, I have to collect like terms, I have to get everything together, then I look for any similarities. So I just do this work. I'm going to do a whirligig here. I have a negative 2x minus 6. I just distributed my negative 2. Then I'm going to distribute my 3 plus 3x plus 3. Once I get that, I'm working down to see what my numerator is. I'm just going to do the work with my numerator until I get it all done. So I have a negative 2x and a positive 3x. That leaves me with x. I have a negative 6, a positive 3, leaves me with 3. So I have an x minus 3 in my numerator. Now you just look for sames. I'll say sames. I like that. I don't want to say similar. Look for sames. X minus 3, x minus 3. Now, one common mistake is people think they go away, and they'll either make it a 0 or they'll just write this left over. Well, what you're saying is it goes into itself one time. So anytime something cancels out, you replace it with 1. That holds this position so that you have a 1 on top. And then in your denominator, x plus 1, x plus 3. For this section, that's what we do. We just leave it like that. All right, that was example 5. We're going to mosey on along here so that we can get through this in a decent time frame. I don't want to go through too many batteries. I finally found my charger, so I can use my good camera for all the remaining videos. I have one battery charging right now, and I have a full charge in the battery that's currently in use. So let's jump to example 6. With example 6, they give us x plus 4 over 2x plus 10, and we are subtracting 5 over x squared minus 25. So again, the key is factor first so that we can see all the pieces we're working with. I'm just going to go down this way, and then I'll move up there probably. I don't know. I'm limited with the size of the whiteboard I'm using, but it's what I had laying around the house before the whole quarantine hit. So I pull out my 2. I'm going to factor out anything I can. Just factor it out until you can't factor anymore. You're basically thinking back to primes. Get prime factors, prime pieces, so to speak. So I have an x plus 4 over 2x, 2 times x plus 5 in this one. Then I'm subtracting my 5, and I have a perfect square minus a perfect square, so that's simple. That's our plus minus rule. Now we see what we have to work with, and for our LCD, again, I'm going to take it piece by piece. I know I need a 2. I need a quantity, x plus 5. I need a quantity x plus 5, but I already have it. I need a quantity x minus 5. Work your way across and basically whittle them up. 2, got it. X plus 5, got it. X plus 5, already have it. X minus 5, there's my LCD. It's what's similar with all the pieces. Okay, so as you get a new piece, you write it down. If it appeared once, you leave it out. You don't write a quantity twice or a number twice. You don't write anything twice, any term. There's my LCD. That's going to be my end denominator. Okay, so now I work with the numerators, and I take my x plus 4. What I know with my x plus 4 is I need to multiply it by whatever's missing from its denominator. So I look at the LCD. 2, got it. X plus 5, got it. X minus 5, I need that. So I include it up here. Then I'm going to subtract a 5. Remember, I'm only working in the numerator right now. I know this is my denominator at the end. So I'm going to work straight across and combine everything. So minus 5. Now I know I'm multiplying by something. X, let's see. I have my x minus 5, my x plus 5. I'm missing a 2. All I have to do is multiply that negative 5 by 2. So now I'm working down here. There's no sense in writing the fraction every single time. I'm just going to work with the numerator until I can start canceling things out. So I have to distribute. I have to combine these two in order to get this negative 10 in there. Once I get that all together, I can factor again. So I'm using basically distributive property here. to combine everything. So I have my x squared minus 5x plus 4x is negative x. I'm just skipping that step. I'm not going to write them all down. Negative 20, negative 10. Now I combine again. I have an x squared minus x minus 30. Now I have to factor. So that's the big issue with these types of problems that some students get hung up on is, yes, I have to distribute in order to combine this piece. Once I get it all in one piece all together and I can add and subtract, then I combine my like terms and I have to factor out again. So I have to factor that piece out. So my negative 30 is a negative 6 times positive 5. The difference is negative 1. That's my numerator. I'm done with my numerator. Now I rewrite my LCD, which was this, and I look for anything the same. X minus 6, I don't have one. X plus 5, I have one of those. So my answer is x minus 6 all over 2 times x minus 5. So there's example 6. Now, I'm going to do a couple, 2 or 3 more, so that we can make sense of this. I'm able to erase at least. This is one nice thing about digital versus classroom is I get to erase these as I go, make room for a brand new problem. You can just pause the video if you need to write it down, need a little extra time. So example 8. We're going to jump to example 8. I'm hoping I don't run out of time. I think I have a 20-minute limit. So I'm doing all right. X squared, x minus 7 plus 6x. You'll see this is a quick one. Over 7 minus x. In some cases, they're trying to trick you. 7 minus x, x minus I can't factor anything out, can't factor anything out. I'm done as far as factoring. But what I see is a positive x here, a negative x here. A negative 7 here, a positive. Since these are opposite of this, I can simply multiply through by a negative 1. Multiplying through both by a negative 1 will give me my LCD just by changing its appearance. I'll rewrite it all down here. When I multiply through, remember these are quantities. When I multiply through by a negative 1, I get negative 6x minus 7 all over negative 7 plus x, which is x minus 7. Now I have an LCD. So now what I can do is simply add right across x squared minus 6x minus 7 all over x minus 7. And then I factor this piece out. And I get a negative 7, positive 1 gives me a negative 7. 7 and 1, there's a difference of negative 6. So then I just take that away, and my answer is x plus 1. And that one's done. That was pretty quick. And then they give us another quick one too. That's example 8. Remember, I multiplied by negative 1. You can rewind if you have to. Go back in time. Be nice to go back in time right about now. So example 9. I'm going to do example 9 real quick. If we have time, I'll discuss example 10 real quickly. When they give us something like this, don't get confused, don't overanalyze. The biggest issue with algebra is overanalyzing a simple problem and making it difficult. Just treat this like 2 over 1. Whenever you have a 1, then you look for your LCD and multiply the numerator by the whole LCD. Since that's 1, I make it equivalent to this by multiplying by 3x plus 1. I just multiply by the LCD. When I do that, I'll have my LCD. I'm just going to multiply my 1 times 3x plus 1. What I do on the bottom, I do on the top. Or think of it as, here's my numerator. What am I missing from my LCD? I'm missing the whole stinking thing. So I multiply my numerator by the LCD. Now, I'll go this way. Now I'm simply going to distribute my 2 So I get a 6x plus 2 minus 9. And I just combine those, and you're going to see there's nothing else I can do in this one. Yeah, there's some big goofy numbers that look like we should be able to do something with them, but we can't. I have a negative 7 here, 6x minus 7 over 3x plus 1. I just leave it. If I can't factor anything else out, I'm done. I have enough time to really quickly talk about example 10. Nothing like example 10 will show up on the test. It's just more or less added analytical thinking. So example 10 just wants us to break this down and think about it. Now, the thing about story problems, usually students hate them. Students hate worded problems in math. They want numbers, they want symbols. Well, when you get a worded problem, make numbers and symbols. Just get rid of the words. That's how you tackle these. You will see them. You'll see them on standardized tests. You'll see them if you're in the trades and you have to take the journeyman test. You will see math problems on there that are worded problems, like story problems. You'll see them in education if you're going into teaching. You'll see them in the business world when you're taking certification tests. You'll see them in nursing with the Kaplan. So this stuff does play a role, so I do want to talk about it real quickly. When you get a worded problem, get rid of the words, change them into numbers and symbols and variables. So write an expression. An expression, you know what we've already been talking about. You want something on top, something on the bottom. You want, when they say write an expression, they go back to that P over Q, something written with one numerator, one denominator. So they say the sum of, you know that's addition, the sum of, got it. When they say a number, I don't know it. Some number, any number, a number, it's X. If they say another number, make it Y. Just use two different variables, a different variable every time they give us an unknown. Then they say, I'm going to break this one up in two different pieces. The sum of a number and twice its. You know twice means 2 times whatever they're telling me. 2 times something. And sum of a number and twice its reciprocal. It is the number x. The reciprocal of x is 1 over x. That means twice, this says expression or sum of a number and twice its reciprocal. Twice its reciprocal is that piece. So for the sum of a number and twice its reciprocal, we have x plus 2 over x. The sum is added. What two things am I adding? A number and twice its reciprocal. So here I've taken the words and I've gotten rid of them and made them symbols, variables, numbers. Now, this is 2 different expressions technically. One plus another. We need one expression. So I need to find my LCD. In this case, it's x. So I need to multiply my x times what's missing. Again, I can say over 1. And I'm going to add the 2 and write it over x. So I just happen to have x squared plus 2 over x. There is my expression to show the sum of a number and twice its reciprocal. Done. All right, that was pretty awesome. 18 minutes. I fall under the 20-minute time frame of my camera. That was 5.3, so I'll shut her down and get back to work and shoot a video for section 5.4.